Corolla, I'll hand it over to you for observer, other comments from people.
So, is there any more comment or question from the PPRP? Okay. Any question or comment from the sponsors?
Yeah, on behalf of PG&E, I'd just like to thank everybody for their attendance and for the significant amount of feedback you provided the TI team. And a special shout out to Corolla for setting up the workshop and making it work for us. And I thought it was an excellent workshop. Thanks, Corolla. And for Andrew helping out the last 3 days, making sure everything ran smoothly.
Yeah, and from APS, I would just like to echo Rich's comments. Thank you very much for your participation. It's, APS's vision or mission is to generate electricity safely and efficiently for the long term, and this project is in direct support of that. So we very much appreciate your participation. Secondly, I'd like to just make mention of operating experience lessons learned with respect to the documentation. In my experience, I find it key to consider the audience that's going to be reviewing the documentation, and for us, the primary audience is the regulator. So to the extent we can anticipate their questions and answer them, I think we'll be much more successful. We can get the questions answered before they're asked, or we can take RAIs, and those could be well down the road after some of you have gone off on other projects, so much easier to answer up front.
Thanks. So, is there any other question? I would like to open the floor for the observers that have joined us. First of all, from the technical observers, is there any question or comment? Okay.
Thanks. So maybe one last comment on the Siemens map that Nico presented, and I would like to follow up a comment of Bob Butnitz he made earlier today, that I think it's important to document in the approach also the assumptions when only one method was taken to produce the output of the maps. As we know, let's say there are various ways on how you could produce these. For example, when you look at the distances or how to map, let's say, the higher dimensional space into 2D space. So I think what we have seen, it's a very powerful tool, and it's also, let's say, great in the sense that from the conceptual point of view, I think we all see that there is a high potential for it. But I think while it's implemented, it needs to be clearly documented to anticipate also questions from later on regulator side of view or the people who are implementing it on what were these small, let's say, pieces that were implicitly built in the representation, how we see it today. Because I think there are various ways on how to do it, and in order to anticipate that others might choose a different way, that we just document that clearly. Thanks.
Thanks. Is there any comment from the regulatory observers? Any comment or question?
Just a very short comment. Please document this, especially this new tricky part, or let's not say tricky, but the cut-off edge science part. It is very important because otherwise it will be very difficult to review this report. This is why, again, it is very important that documentation, especially about sigma and Nika part visualization should be documented.
Thank you. Any comment from our observers that attended all 3 days here? Very much appreciated.
Thank you. My name is Sherry Lewis. I'm from the San Luis Obispo Mothers for Peace. And the two comments I want to make is not understanding a great deal of this. I am overwhelmed with all the detail, which made me think that I hope all this detail that you were quibbling over, which I'm sure is important, reflects the basic choices that were made in the very beginning, so that all the leaves on the trees, not the logic tree, but all the detail leaves on the trees reflect the right tree, and that you haven't made wrong assumptions in the beginning because you're spending so much time on these details. And the other thing is, that's kind of related to that, is of course I'm simply against nuclear power itself because of the high toxicity of the waste and the long life and just the permanence or semi-permanence of the radiation. And I kind of hate to see all of this work go into making something like that viable. It's a dangerous thing. It shouldn't be here. It's only been here within my lifetime. Before 1940s, there was no nuclear power. And I would like to go back to that. Of course, that'll just knock me out right away. But in any case, pay attention to what you're doing. This is poisonous stuff, and we want to get rid of it. So that's my comment.
Thank you. Am I coming through on this speaker? Okay, I have several questions and comments based on the last 3 days of proceedings, which I think represent the real cutting-edge, state-of-the-art in analysis of data and perhaps in a selection of data. But my first question has to do with the overall world of seismic data that are used in these analyses, and that is a question of whether a couple of what I believe to be quite significant but old-fashioned real-world earthquakes might have entered into the database. There was mention both by Professor Heaton and by Professor Idris of extreme events, and Professor Idris earlier today brought up the subject of the San Fernando earthquake of 1971. As it happens, there were two earthquakes that really played a very significant role in the original licensing of Diablo Canyon, and not in the development of the original seismic design, which happened before either of these earthquakes back in the 1960s, but rather in the so-called Hosgray reevaluation of the mid-70s, and in the further examination of the earthquake conditions during the appeals board hearing of 1981. Those were first the San Fernando earthquake of 71, and second the Imperial Valley earthquakes of 1979. In the case of the San Fernando earthquake, this, as I'm sure everyone knows here, generated this remarkable PGA of 1.25 at the Pacoima Dam station, which is located about 4 kilometers above the rupturing fault that created the earthquake, and around 10 or 12 kilometers in a horizontal direction in the up-dip direction from the hypocenter of that earthquake, which was at about 12 kilometers depth, farther to the north in that case. That record, I know, has been the subject of much debate, and whether it was really 1.25 or perhaps something less than that. I don't know that anyone has truly made a final decision on that. I know that when one goes to the Pacoima Dam and you look at the amount of steel that had to be drilled in and placed as tendons to stitch the left abutment of the dam from the shattered rock there right below where the recording instrument was, you know that there was pretty serious ground shaking there. If, as I recall, it was the presentation on directivity, which presented evidence that the strongest ground motion is likely to be over the actual down dip point of origin of a reverse fault. And if that's the case, then we're about 10 or 12 kilometers from the down dip end of the San Fernando Fault that ruptured in the 1971 earthquake. And it's conceivable, if that's really the way earthquakes work, that the ground motion at the surface above that hypocenter might have even been stronger than 1.25. But there was no instrument there to tell us that. The results of the San Fernando earthquake were initially dismissed by the AEC on the basis of a letter they got from their then principal seismic consultant, Dr. Leonard Murphy, who had been of the Coast and Geodetic Survey and then NOAA, who wrote them a letter saying that, well, the tectonic conditions at Diablo Canyon are completely different from those at San Fernando. So there's really no reason to consider the San Fernando Fault as a factor in the assessment of the seismic hazard at then under construction Diablo Canyon. Later, of course, that did get to be a factor, and Professor Newmark then, I think, was probably the main developer of the concept of tau based on records from that earthquake, which enabled him to lower the maximum spectral acceleration by about maybe 20% or thereabouts, and thereby bring it within the realm of what the plant had been designed to withstand and allow licensing to proceed. So that was kind of the background of that earthquake. The Imperial Valley earthquake of 1979 was a strike-slip earthquake, which was well instrumented because the USGS had been lying in wait for it after the 1940 Imperial Valley earthquake occurred. And so it was also well instrumented with strong motion seismometers. And it produced kind of surprising results. I think that some of the recordings were above 1G, and some of them also showed at least as much vertical as horizontal movement, which was somewhat at variance with the accepted belief at the time. That earthquake featured very largely in the hearing in 1981, but the applicant got past it and the plant was duly licensed. So my question is, even though those are earthquakes that are not modern instrument type recordings, are they factored in any way in the data set that has been used for all of the different analyses that we've heard about for the last 3 days, or are they somehow or other screened out because they don't meet standards of recording criteria?
They are included. Is the
They are
short answer.
included.
Including the Pacoima Dam recording is included in all the Imperial Valley data as well. So none of that is screened out. In fact, older records like that from big earthquakes are really important for us.
So that is part of the somewhere between 2 and more than 800 events that are the basis for the various analyses made today.
Yes.
Okay. Well, that's reassuring to me. The second point has to do with the effect of ruptures extending from a main fault onto a branch fault. And so far as I'm aware, one of the best documented examples of that is the Denali earthquake of 2001, in which the southward propagating rupture along the main Denali fault veered off onto the branch Tochuna fault. My question is whether there was evidence that there was a 60% reduction in the radiated energy from the fault after it went onto the Tochuna fault, or whether it just continued along as though it had still been on the main Denali. Any knowledge of what information there is on that?
I don't know what you mean by a 60% reduction. So we didn't have strong motion data up near that reverse end. There was data along the strike slip part, but I'm not understanding your question about a reduction.
Well, I raised the question because, as I understood, the analyses that were presented here envisioned about a 30% of the basically, I guess, the energy release on the branch fault of that on the master
this is the
fault.
amount of slip that would be put onto the parallel fault. So not just the Denali Tachunga we would call a complex rupture of a reverse going onto a strike slip. In that case, there is no scaling of what's going on or change in the amount of slip. Where we used a smaller slip was if you had two parallel sections and you had main slip of 2 meters, what would be and then a parallel slip, for example, on the Brawley Fault during the 1975 Imperial Valley earthquake, where you had a main rupture and then the Brawley splay fault. So the geologists have said from past earthquakes, they see those are typically more like 10%. We tripled that to be 30% because we wanted to get a larger numerical effect out of that modeling. But it's not analogous to Tachunga Denali. For us, we would just model those as full ruptures. And that's how those were addressed in a previous session that I had just described, sort of the summary of the technical work there, which we call a complex rupture, where there's a change in dip and rake along the rupture front, as opposed to a splay rupture where you have a main trace and then a parallel splay coming off of it.
So is it felt that Gene Hardebeck's observation that the possibility of a rupture continuing between the Hosgri and the shoreline fault to generate a magnitude 7.2 earthquake effect on the shoreline fault, as I understand it, that would preclude that sort of
No,
seismic effect?
that's a different case. That's the rupture from the Hosgri coming and then onto the shoreline, and not two parallel strands going. That's part of what's in the source characterization model of linking ruptures together, and those are being considered. In our part, we would simply use the distance to the shoreline fault and the full magnitude of 7.2 at that distance to estimate the ground motion.
So if I understand this correctly, then one would have the possibility of the magnitude 7.2 continuing onto the shoreline and yielding whatever ground effects that yields at a distance of 600 meters from the site.
So for us, that comes from the source characterization, so I don't want to tell you what they're going to say. In 2 weeks, you'll, I think, get that answer. If that case comes from the source characterization, we would compute the ground motion using the full magnitude at the shortest distance.
Okay. My third question is just, I guess you might say, an idle speculation. There seems to have been much moving of events from one place to another in order to create a kind of a coherent basis for analysis. And there is this shortage of larger earthquakes, or very many earthquakes, in the Irish Hills adjacent to the Diablo Canyon site. I was wondering if it might be possible to just basically extract the 3D pattern of the San Simeon earthquake, main shock and aftershocks, of which there were some 10,000, many of which apparently were well enough recorded to give both a hypocentral depth and a focal mechanism, and translate that to the Irish Hills and scale up the earthquake a bit and see what kind of effects that you got from doing that real-world example in a similar setting at the Irish Hills.
So that case was discussed here in what we had of the splay faulting, so a main fault with a conjugate reverse fault. And we did it with San Luis Bay and the Los Osos faults. For us, again, we computed the ground motion for that case, the exact geometry. So we have the rules on how we would estimate the ground motion for that occurring. How that happens, its rate of occurrence and exact geometry is back to the source characterization. So I don't want to overstep my bounds. It's up to them to talk about that, and that's in 2 weeks, so I think you'll catch that as well. So I believe that is a case we are anticipating to be in the source model, so we wanted to be sure our ground motion model will be knows how to work for that that
So
condition.
that will be basically tested against what was actually observed in the San Simeon earthquake case.
There wasn't very much data really close in San Simeon right over the faults to do that kind of a test. If we had had a nice array across that, then it would be really good, but most of the data are further away or off the ends of the rupture from that earthquake, and they don't give us a direct measurement of what the strength of shaking was directly over that, over the source.
But you did have at least the main shock, and you had the both
So
the
San
principal
Simeon
thrust
data is
going
in our-
one way and the back thrust going another,
Sure.
which presumably corresponds to the Irish Hills condition.
Correct, but the San Simeon earthquake is in our data set. It's one of the earthquakes that we consider, and so it's part of that full set that we're using. So we have, I think, every large earthquake in California and most of the big ones around the world are in this data set. The peer data set is, it's the best strong motion data set that's been compiled anywhere. I think I can say that pretty clearly. And so any big earthquake that happens, we go collect the data, we collect the site conditions, and bring it in. That takes several years, and that's a continuing process. Yusuf's nodding his head. That is really nonstop. We're now adding the next sets of earthquakes as they come in to bring them into that database.
Yeah. The reason for my first question was that I seem to remember day one that in describing the proceeding with setting up the data set that you used, that you had fairly specific criteria for the number of stations and the at which records were accepted and so on. So it sounds like you have either
Right, so an earthquake with just one
modified that or gotten
recording
around it.
is not very useful for it. It's hard to use, okay? But earthquakes like San Fernando and earthquakes like San Simeon with lots of recordings, earthquakes Totori that Tom Heaton had talked about are brought in because those are key ones for us. Earthquakes with single records just have so much variability because we can't tell, is it a path effect, is it a site effect, is it a source effect, because I only have one recording. It's hard to then assign it to that. So we do have enough data now that we can bring all these along. I can tell you that none of the data were rejected because of amplitudes. If anything was rejected, it would be, it was in a, it was not free field being, it was in a large structure. Well, that's not going to be the same type of ground motions. But if you look through the data sets, you'll see how everything has been classified. These data are public, so you can look through the peer flat file. It's just a big spreadsheet with all of the recordings, and you can pick out the Pacoima Dam record and see how that's in there.
Thank you. That was a good comprehensive response. No further comments.
Thank you so much. So we are getting ready to adjourn. I want to thank personally everybody for the attendance. Great, big thank you for the sponsors for their continuous support. A big clap to our TI team. They have done a tremendous amount of work, very much appreciated. The comments and the feedback received from the PPRP have been very useful. Comments received not only through this workshop, but also through the working meetings that we had so far to get to this point. So we are looking forward for continuing this collaboration and this interaction towards the finalization of the model. Thanks so much also for our valuable resource experts for the amount of critical and very constructive comments that I think we have recorded and that will keep us in a good track towards the finalization of this model again. Thanks again to our hazard analyst, our support team. Big thanks to Nico. He has been running these maps and these analyses throughout the weekends, day and night. He has been a tremendous help for this project. And also thanks for Andrew for helping with the technical needs. He's overly qualified for this role, but it was very much appreciated. Thanks so much also to the other observers that took their time to join us. Very much appreciated. people coming from abroad, from far away. Again, very much appreciated. We are going to issue documentation and proceeding for this workshop in the same manner as we documented the first two workshops. Technical presentation, link to videos, and then proceedings will be available on the project website that was shared with you on, the link was shared with you on the first day. Attendees for this workshop are also going to be documented, in-person attendees, and also connected with us via GoToMeeting. All these attendees have been properly documented, and they will be in the proceedings. Again, thanks so much, and thanks.